Hi everyone, and welcome to video 5B, which is trigonometric ratios defined. And you see that funny word there. We're going to talk about what that means here in a little bit. Just wanted to remind you, hopefully you already see it at the top of the page and you've already prepared yourself, but please make sure that you are paying attention to be fit and to check your tech as you are watching your video here. This is for education and not entertainment, and remember there's a difference. So just that little reminder. Okay, so let's begin. To begin our lesson today for trigonometric ratios, and that is, by the way, how you're going to hear me say that word, trigonometric, there's three new definitions that you need. If you want to go ahead and just keep your vocabulary in these notes pages, you're welcome to do that, or if you want to get your separate vocab builder sheets, that's fine too. But I'm going to just import little pieces of vocabulary kind of right into your notes here, so you're welcome to just keep it in there like I said. So the first three terms that we're going to need probably are some that you've dealt with before, but just wanted to remind you, of course we have our hypotenuse, which we know. Is the side of a right triangle that is opposite the right angle. Okay, so if we have our right triangle diagram here, and then we put in our right angle symbol in the corner, and then we're going to go ahead and make sure that this side right here is highlighted as the hypotenuse. Okay, then we have the opposite leg. And that is the leg. Remember, the legs are the ones that come together to form the right triangle that is opposite the angle that you are talking about. And it is going to be an acute angle of that right triangle. So here's our picture again. We already know in this right triangle here that the hypotenuse is taken, so it cannot be the hypotenuse. We want to just make sure that we always call the hypotenuse. So we're not going to call that one of the legs. It's really important to keep in mind that whenever we're talking about either the opposite or the next definition, which is the adjacent leg, it's always in reference to wherever I am, whichever acute angle I'm kind of sitting at position-wise in the triangle. So let's say that if I draw my star right at this corner, we want to find the opposite leg, which would be the leg opposite this acute angle right here that I put the star on, and so that's going to be this side. That's the opposite leg. And then the last definition I've already mentioned, but it is the adjacent leg. And again, it's going to be a leg, so one of the sides that comes together to form that right angle. But this is the leg that is next to, which is what adjacent means, the acute angle that you're talking about. So here's my diagram. Here's my right angle. We already know that this is the hypotenuse, so that is not qualifying as a leg. And again, if I'm sitting at that bottom acute angle there in the corner, then this time the adjacent is going to be this leg right here. Okay, so those are our three definitions that you need to know to start out trigonometric ratios in this section. Of course, you knew hypotenuse already. We have opposite leg and we have adjacent leg. What we're going to do now is we're going to start to practice some identifying of these different legs here. So we're going to look at this diagram in the corner here, and that's going to be in reference to each one of these four questions. So first off, we're going to start with this first one. What is the length of the side that is opposite angle A? So if I go ahead and I put myself here at the corner at angle A, just kind of like the pictures that we were doing up here, if we look where opposite is, if this is angle A, then that is going to be side little a if we look at the diagram as it's labeled here. Then we're going to think about what's the side adjacent to angle A, and again we're sitting in this corner right here, and we don't want to go ahead and use the hypotenuse. The hypotenuse is C, that's not a leg, remember. The legs are either A or B, and we have the side that is adjacent to angle A is going to be side B. Notice these are little lowercase letters. Remember to make a distinction between capital letters are angles and lowercase letters are sides. That's an important distinction for us to remember in our notation as we go through the rest of this section and this unit really. Then we're going to switch gears and we're going to talk about, now I'm going to sit myself up here at angle B. So what is the length of the side that's opposite angle B? Opposite angle B would be right here, and that is going to be little b. And then the length of the side that is adjacent to angle B, and here's angle B, and the side that is right next to it is going to be side lowercase a. Okay, so that's going to be what you need to know to identify what the difference is between opposite leg, adjacent leg, and of course you already knew hypotenuse. So just keep in mind those vocabulary words as we move on to the next page, which talks about now ratios of those sides. So let's move on. Okay, going to the back side of that notes page, we're going to start with some new vocabulary words. So again, if you have a vocab builder sheet in front of you, that's great. If you want to just take notes here, that's fine too. But there are 3 different basic ratios that we're going to use throughout the unit in trigonometry that you need to know. Their names are sine, which is S-I-N-E is how you would spell that, but our abbreviation that we're going to use most often here is just going to be the S-I-N abbreviation for that. There's 3 letters that's the abbreviation for each one of these ratios. And then there is the cosine ratio, which is again S-I-N-E is the ending. Its abbreviation that we're going to use most often is COS for cosine. And then the last one is tangent, and its ratio is TAN. So if you had a graphing calculator in front of you, you would see 3 buttons with those abbreviations, sine, cosine, and tangent in 3 letters on the buttons that you would see there. Those are going to be definitely important calculator buttons for us to know how to use. We're just not quite going to talk about how to use our calculator for those ratios quite yet. We're still just working on identifying them. So now let's talk about the definitions for these. If we go back to sine, sine is going to be the definition that is the ratio of the opposite leg all over the hypotenuse. The cosine is going to be the adjacent leg divided by the hypotenuse, because remember, every time we talk about a ratio, we're talking about a fraction, so we need a numerator and a denominator, and that's what we're looking at so far. Then the final ratio that we need is tangent, and that is going to be the opposite leg over the adjacent leg. Okay, from there, once we know those 3 ratios, I just wanted to let you guys know that there's this pretty cool mnemonic device that is able to help us remember and be able to use these 3 ratios, because it tells us as we say the word, it tells us what the parts of those ratios are. This word, you saw it on the first page, but it's pronounced Sokotoa, and there's a lot of different ways to remember it, but I like this one, and I cannot take credit for this one. This one is from Mr. Fricero, actually, is the one who told me. told me about this particular version of the SOHCAHTOA mnemonic device, and I think you guys will find it pretty memorable. Alright, the mnemonic is the following. Some old horse caught another horse taking oats away. So it's a little silly, but you can see that the stacked letters here are the sine, cosine, and tangent ratios. So some old horse caught another horse taking oats away. It's just an easy way to remember the SOHCAHTOA or SOHCAHTOA, if that's how you choose to remember it, the mnemonic device, so that you can remember your ratios. The first letter of each one of those stacks you can see is the ratio's name. So meaning sine, cosine, or tangent. The second letter in each of the 3-letter groupings is going to be the top part, or the numerator, of your ratio. And then the third letter is your denominator. So when you are given a problem in your next practice set, you're going to hopefully refer to that to remember, okay, if I'm being asked for tangent, then that's taking oats away. So opposite over adjacent, or oats away there. So that's what you're going to do. Okay, we're now at the cue part of our whisk for today. The cue is always either the question that I would like you to finish, or the one that I ask you that you need to jot down from the video to prove to me that you've watched the video all the way through and done what you need to do. So for today, we're going to make this our question that we need to look at. I'm going to have you guys go ahead and just finish question 3 once we've done the first 2 examples together. I think you'll get on the hang of it pretty quick here. But what we're being asked to do is we're being asked to, in each triangle, find sine of j, cosine of j, tangent of j, and then sine of L, cosine of L, and tangent of L. And notice, please, that the j and the L that it's talking about are always the acute angles of this right triangle. We're never going to be finding sine, cosine, and tangent of anything except for an acute angle in this right triangle trigonometry. So let's get started. On this first one, when we have sine of angle J, we're going to sit ourselves at this part of the triangle, and remember, in SOHCAHTOA, I have that in front of me, and I know that all the 3 letters kind of separate into those pieces of the ratio that we need. If we want sine, we want the opposite of angle J over the hypotenuse of that triangle. Well, the hypotenuse is easy. We know that's 20. We just need to know, is it 12 or is it 16 that's opposite J? And I hope you can agree with me that the opposite is going to be 12. So that's sine of J. Next we'll move to cosine of J. And at this point, you guys, we want to make sure that at angle J again, we want to go to the leg that is adjacent to J. So remember, we're not going to be using the hypotenuse of 20. We're going to be looking at the adjacent leg, which is 16. So that's 16 over 20. Hypotenuse stays the same. And then finally, the tangent of J is going to be equal to, tangent is opposite, which we already know is part of the sine ratio, so that's my 12, over adjacent, and we already know that from my cosine ratio part of it, so that's 16. So then the only thing left for us to do, guys, is just to reduce these ratios. So 12 over 20 is going to become 3/5. Cosine 16 over 20 is going to become 4/5. And 12 over 16 is going to become 3/4. Interestingly enough, if I thought back to how this 12, 16, and 20 triangle comes together, I hope that you can see that it's going to be based off of, you guys, are 3, 4, 5 triple. There's another reason that I wanted you to get to know those triples, because you're going to see them a lot. Okay, I'm going to slide down here so we have a little bit more room as we're looking at the rest of this triangle. Then we want sine now of L, cosine of L, and tangent of L to finish this off in this problem. And so we're going to be sitting at this corner now of our right triangle. And so as I think about what's opposite that angle L, that's going to be 16 over the hypotenuse is still 20. Cosine, sitting at this angle L, the adjacent leg, that's got to be 12. And that's going to be 12 over 20. And then the tangent of L, I hope you can agree, would be 16 over 12. And again, just reduce those fractions. So we have 4/5 for sine, 3/5 for cosine, and 4/3 for tangent. Okay, let's move on to the next problem. Forgive the amount of room here I took up on this first one. Let's go back up and look at the full triangle for number 2. And for number 2, we're going to go ahead and again repeat that same pattern with some new measurements. So we have sine of j, we have cosine of j that we need, and we have tangent of j. Let's find those. So we're going to go ahead and sit ourselves up at the top here at angle J, and we're going to try and find the, first of all, sine SOHCAHTOA, so opposite of angle J is 24, hypotenuse is 40, cosine of angle J is going to be 32 over 40. And then the tangent of angle J would be the opposite. Again, grab that from the sine, which is 24 over the adjacent. Grab that from the cosine, is 32. And if we reduce these, again, if you look at the common factor for all three of these sides here, they all have a factor of 8 in common. And if I boiled this triangle down, I've got another 3, 4, 5 triple here, you guys. So just be aware that as I reduce them, these are going to be some familiar numbers. Here's my 3/5, here's my 4/5, and here's my 3/4. Kind of interesting. Okay, now we're going to switch places in this triangle, and we're going to be down at the other acute angle, angle L at this point. We again need to find sine, cosine, and tangent. And we're almost to the point where you guys are going to be working on your own here. So sine of angle L, if we sit ourselves in this bottom corner, the opposite, remember what we're referring back to. We're referring back to SOHCAHTOA all the time. So sine is opposite over hypotenuse. And we're going down to sine of L. So sine of L is opposite of L, which is 32. Over hypotenuse stays 40. Cosine would be the other one, so 24 over 40. And now the tangent of L, again we want to go opposite of this angle first and then the adjacent. And so that's going to be 32 over 24. Again, reducing those fractions down, sine is going to become for me 4/5. Cosine is going to be 3/5, and tangent is going to be 4/3, you guys. Alright, we're at the point right now where you can go ahead and look back up at number 3 on your own. Do make sure that any radicals that you have, you're putting into simplified radical form. So if you need to take care of denominators and multiply by radicals to do that, don't forget to do that, but simplified radical form, okay? And that is trig ratios, you guys. That's the video 5B is all done. Once you finish that problem, I'll see you guys tomorrow.